We can apply our exponent rules to answer these questions. Let's start with the first one. It's a negative exponent. Since it's a negative exponent, we can rewrite it 1 over 8 with a positive 2 exponent. 8 to the exponent 2 is 64, so our answer is 1 over 64. Our next example has a 0 exponent. Remember the rule, any number to the exponent 0 has an answer of 1. Our next example, we have a negative exponent, so I can rewrite that with a positive exponent, and then I can get my answer. We also have a negative exponent in this question, so I can rewrite it with a positive exponent and get my answer. Now in example 2, I'm going to use all of my exponent rules that I know so far. In this question, I'm multiplying powers with the same base. And if you remember, when you multiply powers with the same base, you add the exponents together. So my exponent is 3 minus 5, which is negative 2. So now I have a single power, but it has a negative exponent. So I'll rewrite it 1 over 4 to the positive 2 exponent. 4 to the exponent 2 is just 16, so my final answer is 1 over 16. In the next example, I am dividing powers with the same base. When you divide powers with the same base, you subtract the exponents. So to simplify the exponent, it's going to be 2 minus negative 5. So my exponent is 7. So I'm multiplying negative 2 by itself 7 times. And my answer is negative 128. The last example here combines a few different exponent rules. First off, we're dividing powers with the same base. And then we're going to raise an exponent to an exponent. So if we just look inside the brackets first, we're going to subtract the exponents. So 2 minus 5 will be negative 3. Now I have a power of a power, so I'm going to multiply my exponents together. So when I multiply my exponents together, it's negative 3 times 2, which is negative 6. I now have a negative exponent, so I can change that to a positive exponent. And if I do the math, 4 to the exponent 6 is 4096. So my final answer is 1 over 4096.